For this example, we're going to talk about finding an acceleration vector. Here we're given motion described by this position vector for all t greater than 0. So we have r of t equals cosine t plus t sine t times I plus sine t minus t cosine t times j. And we're going to write this acceleration vector in the form that we defined previously. The vector A equals the tangential component times the tangential unit vector plus the normal component times the normal unit vector. But we're going to do so without finding t or n directly. So looking at this equation, we have position, we need to find acceleration. One thing we know is that the derivative of position gives us velocity, and then the subsequent second derivative of position, or the first derivative of velocity, gives us acceleration. So we're going to start here by finding our velocity vector, v of t. So I need to differentiate each of these components. The derivative of cosine is negative sine. When I go to find the derivative of t sine t, I have to use the product rule. So that is first derivative of sine is cosine t plus sine t, and the derivative of t would be 1. As well as the derivative of sine is cosine t minus, first I would have t, derivative of cosine is negative sine t, plus cosine t times the derivative of t, which is 1, so I don't need to write that, and then I've got my j. Notice I didn't put my parentheses in here nicely, but this minus is going to distribute over through here. So I have negative sine plus sine. Those are going to go away. My velocity vector, v of t, I'm going to have t cosine t times I. Here I have cosine t minus cosine t. Those go away, and this becomes positive sine t. So I have t sine t times my vector j. Now let's look at calculating the magnitude of v. So the magnitude of v is the square root of t squared cosine squared t plus t squared sine squared t. That cosine squared and sine squared are going to turn to 1 by our Pythagorean identity, which we know from trig. So I've got the square root of t squared times 1, which gives me the absolute value of t. And since we know t is greater than 0 because it was specified, we'll just say that the magnitude of the velocity is t. So by the formula that we stated, we said that a of t, a sub t, was the derivative with respect to t of the magnitude of the velocity. And the magnitude of the velocity is t. So we're finding the derivative with respect to t of t, which is 1. So this is my tangential component of acceleration. So I've found my a sub t. I need to find my a sub n. And we wrote a formula for calculating a sub n. We said that a sub n is equal to the square root of my acceleration vector, the magnitude of that squared, minus a sub t squared. So acceleration, that should be pretty easy for me to find. That's the derivative of velocity. So I'll find this a piece. I have to do the derivative of each of these components we have up here. And again, we're going to use the product rule. So I have t times the derivative of cosine negative sine t plus the first cosine t times the derivative of t, which is 1, plus t times the derivative of sine is cosine t, plus sine t times the derivative of t is 1. So there's my acceleration vector. By this definition for a sub n, I need the magnitude of this. So the magnitude of acceleration is the square root of negative t times sine t. So negative t sine t plus cosine t squared plus t cosine t plus sine t squared. So once I simplify this, I'll have this value, and then that purple value, a sub t, will plug in there. That will let us finish this problem out. So this is a little messy to FOIL out, but I know you guys can do it. I'll leave that on the screen. So FOILing the magnitude of a, square the first, t squared, sine squared t twice their product would be minus 2t sine t cosine t plus cosine t squared plus t squared cosine squared t plus 2t sine t cosine t plus, running out of space, sine squared t. So you see these two terms are going to cancel, my 2t sine t cosine t. Cosine squared t plus sine squared t is going to equal 1. So I'll just clean this up a little bit. Magnitude of a is the square root. I have t squared sine squared t plus t squared cosine squared t, and that's coming from this term, and then cosine squared plus sine squared is equal to 1 by the Pythagorean identity. And of course, we should be able to see that if we factor this out of these two, we're just going to have t squared times sine squared plus cosine squared, which is just 1. So we've got the square root of t squared plus 1. And that represents the magnitude of my acceleration. So if I want to calculate a sub n, I'm going to plug my 1 in here and square it, and then I'm going to plug this that we've just calculated, the magnitude of my acceleration vector, which is the square root of t squared plus 1. That's going to go in there, and I'll square it. So here we have a sub n, our normal component for acceleration, is the magnitude of a squared. And if I square this, the magnitude of a squared, the square root's going to go away. So I've just got t squared plus 1 minus my tangential component for acceleration. And we said that was 1. So minus 1 squared, which we know is just 1. So I end up with the square root, because those ones cancel, of t squared, or that a sub n equals t. So I didn't find n, and I didn't find t. I found velocity and acceleration, as well as both of their magnitudes. And now, to finish my problem, a, we said we had 1 of my t vector plus t is going to come right in here, t of my normal vector, or rather a equals t plus little t n.